Hey everyone, welcome back. In this video, we are talking about network architectures, and we are going to specifically be talking about the three-tier architecture. Now, there's a few different network architectures that we're going to go through in this course. It's really hard to talk about the rest of them without the three tiers. So for example, if you're looking at your Cisco exam blueprint and you're looking at the topics that you need to know, you're going to notice that the two-tier is actually first. Well, it's really hard to understand the two-tier without understanding the three-tier, because the two-tier, otherwise known as the collapsed core, really came from the three-tier. So all of the other network topologies came from what we're going to talk about today. Now, the three-tier architecture, again, just based on the name itself, similar to PoE, is going to have three different layers, three different tiers, and I've kind of outlined them for you here to read along as I talk about this. But in these three tiers, the access layer, let's talk about the access layer first. The access layer is basically going to be for your user access. So this is what's going to allow your users, so imagine, you're down here, this is what's going to allow your users to actually access your network. So let me just change colors here really quick. On these switches here, these access layer switches, these are going to be the switches where you're essentially assigning VLANs. So you may have printers, they may be on one network, right? So your printers, let's just draw this out here. So we'll say print. These might be on something like 192, 168, we'll say 1.0 all the way to 254, or otherwise known as a /24 network. You may have your, let's say, laptops. These guys might be on 192, 168, let's say 2.0, right, /24. You may have IP phones. So we'll just say IPP for IP phones. And they're going to be on another network, 192, 168, we'll say, what are we on, 2? So we'll say these guys are 3.0. So these are all different networks that you may have all these different devices on, and each one of these different networks is going to relate or translate to a separate VLAN or virtual local area network. And so you're going to configure all of those VLANs on this layer down here. So you're going to essentially say, okay, I'm going to control what VLAN that device is connected to as it comes onto the network. So this is where you're going to do that down at your access layer. Your access layer is also going to be known for what we're going to talk about later on, which is spanning tree. So you're going to have redundancy built into your network. If you're looking at this topology, by the way, I kind of stole this picture from the Cisco Press book back from, I don't know, 2007 or something like that, or 2017, somewhere around there, only because I figured you guys are going to be Googling this stuff. You guys are going to be looking this up. And I wanted you to see a familiar picture so that you understand what you're doing, you're reading and things like that. So I kind of stole it. But anyway, down at the access layer, this is where, spanning tree is going to be taking place. That's where it's going to be saying, okay, am I going to make this port a forwarding port? In other words, am I going to allow traffic here? Am I detecting traffic from other switches that I really shouldn't? This is also where you're going to have your PoE switches, where we were talking about before, where you're going to have those IP phones. Here they are down here. You're going to have those IP phones that are joining your network. They're connecting into your network. You're going to have those wireless access points down here. These are your access points here, right, providing wireless access out to, these various different machines. So this is where you're going to have PoE. It's also where you're going to have quality of service. Now, we didn't really talk about QoS yet. I'm not sure. I'm kind of recording these videos based on the blueprint as I go along. So I don't know if QoS is a part of it, or if it is, I don't know where it is. So I know we didn't talk about it, but quality of service, essentially what that's used for is, as that device joins your network, so that could be a server, it could be your email server, it could be internet access, it could be essentially where we really use quality of service is really more for streaming machines and IP phones, right? You want your voice quality, you want your conference calls to not have a glitch, you don't want them to be dropping traffic or dropping packets. You certainly don't want during the conference call, you don't want the person sitting next to you who's streaming Netflix to get priority traffic on your network over your, your conference call, your Zoom call or whatever. So quality of service is essential to this network, and this is really where we're going to start that. As that traffic comes in, let me pick a different color here. As that traffic comes in from your IP phone, that traffic is going to get tagged, and then that tag is going to essentially is going to stay with it as we go throughout the network to make sure that our voice traffic has priority. Anyway, This is also where we're going to do things like port security. So what does port security mean? Well, port security, I want to make sure that only maybe approved workstations or approved machines are joining my network. I want to make sure that, let's just say that I know all of these machines belong to me. Maybe I'm going to grab their MAC address and I'm going to say, okay, Mr. Switch, only allow these specific MAC addresses to join that switch. And so the access layer is where we're going to do all of that low-level security that's based on individual computers or individual IP phones. The access layer is where we're going to have all of our users and all of our endpoints and all of our things joining our network. Now, that's going to be plugging into, let me erase this ink here. That's going to connect into the distribution layer. Now, you'll notice here in our diagram that the distribution layer has a little bit more redundancy than the access layer, right? So if you're looking at the access layer down here, it's typically a one-to-one. So this, this desktop's plugged into the IP phone, the IP phone's plugged into the switch. That's a one-to-one port. But then you'll notice at the distribution layer, this distribution, these switches here, they have redundancy. They're connected to every access layer switch, and they're connected down this way, so that if one distribution switch goes away, all of these access layer switches can still communicate back up in order to get to the internet. So if this switch were to go away, this traffic may go through here and then go out that way or something along those lines. So you're generally not going to have a ton of redundancy in your access layer. You're going to have more redundancy as you start to build out and get to your distribution layer. Now, your distribution layer is what's going to give you your policy-based network access, right? So what I mean by that is I mean things like access lists. So this is where you may have a firewall in your environment. I don't have one listed here, but this is where you may say, okay, with this firewall here at the distribution layer, if this desktop here wants to, communicate to this desktop down here, let's just say that this guy's on VLAN 10 and this guy's on a completely separate network, we'll say VLAN 20, and he wants to come up and communicate with that other VLAN, maybe we pass that traffic through a firewall, and that firewall either allows or denies that traffic going down. We can also do that with what we would call an ACL or an access list on the distribution switch itself, where we say, hey, we don't want to allow traffic between these two VLANs. Now, generally speaking, we're not going to block traffic like that. Most of the time we're going to allow it. But remember when we were talking about different kinds of switches and we were talking about what the different kinds of switches do? Well, these switches down here are generally going to be layer 2 switches. You're 99.9% of the time, you're not going to have a layer 2 switch. A layer 3 switch at the access layer where all of your endpoints are joining, because there at the access layer, it's port density, right? We're plugging in everything. That's what we're worried about. We're not worried about speed here. We're worried about being able to plug everything in. So we're going to go with cheaper switches that don't have a lot of features because we just want to plug things in. Whereas up here at the distribution layer, we're generally going to have a layer 3 switch, because there's no way that a guy here on VLAN 10 can talk to another guy over here on, let's say, VLAN 15. There's no way he can talk to a guy over here on VLAN 20 without routing, without layer 3 routing in the middle. And a lot of times we're not going to put a router here because we have those layer 3 switches that are capable of doing routing as well as switching. And so what that means is that we can still have all of our VLANs listed here on these switches, but they can also route at the same time. Now, at the distribution layer, also known as the aggregation layer, let me actually put that over here. I'm just going to put ag, because if you hear aggregation layer, it's the same. Those two terms are used interchangeably. And so at the distribution layer, we want that traffic to start we want it to start getting faster. So at the distribution layer, we're generally going to have a lot more, not only redundant links, but we're also going to have faster links, because we want that traffic to come up from that access layer, hit the switches, go, oh, okay, cool, I need to get over here. So we're not worried about being able to plug things in at the distribution layer. At the distribution layer, we're starting to worry about speed. And then the fastest layer is going to be the core. So the core layer is essentially the main brains of your network. That's where you're going to have the most redundancy. You can see here that we actually have 4 links that are connecting these two switches together. You can obviously see the redundancy between the distribution and the core layer. But here's where we're worried about the fastest transport that we possibly can have, because this is where we may have other buildings. The core is generally going to be what connects everything together. So this is just here, if you think about it, this could be just one building, right? This could be maybe this is one campus here, and maybe this part, is a main maybe the center of your campus, right? So this here is the center of your campus, and then you maybe have dark fiber that's going underneath the, under the ground to connecting all your different buildings together. So what's going to happen out here is you're going to have another building connected to your core, another building connected to your core, and each core is going to have, or I should say each building is going to have its own distribution layer at the beginning, or I should say at the base of that building. And then from that distribution layer, you're going to see another access layer. So we'll just say AL for access layer. So this is essentially AL. This is essentially how that network architecture is going to function. And so this is in a layer 3 topology. This is how you would connect it. This is how you would build it. And then obviously the last part of this architecture is being able to connect out to the internets, right? So from the core, that's generally where you're going to have your internet router. And, again, building in redundancy, because in a real network topology, it's generally not going to be a one-to-one. You're most of the time, you're not going to have, one access switch plugged into one distribution switch. You're going to have redundant links. And again, going back to spanning tree, this is where spanning tree is going to do its job. And it's going to say, okay, which one of these links am I going to choose to be a forward link? And which one am I going to choose to be a backup link? And again, I'm not using correct terms here because I just want you to understand what this is doing. So this is where we would use something like spanning tree to decide, okay, this link's going to be forwarding, this link's going to be backup. If this switch or that link goes away, spanning tree is going to make this link a forwarding link and then be able to pass traffic that way, going up and down the stack. That's essentially how this network topology would work. And then again, up here, that's where you're going to have your internet routers. And again, you're going to have that redundancy built in so that no matter which link goes down, your core can always forward traffic out to the internet. So I hope this wasn't too confusing for you guys. Again, as we go through the course, as we start building some of this stuff out, we're going to lab this. We're going to actually build this network topology. We'll show you guys how this all works. So we'll get there. Here, we're just explaining, we're just kind of laying the groundwork and how these things function. In the next video, we're going to talk about a two-tier architecture where we actually collapse the core and the distribution into one stack. I'll see you guys in that video.